All right, so this is 2011 question number 1, which means it's a calculator active question, so make sure you have your calculator handy. We definitely are going to store the function to make it easier. Again, they give you an interval. 0 to 6, and they give you a position function. So actually, no, they don't. They say position is not explicitly given, but they give you the velocity function. All right, and actually they give you the acceleration function, so I'm going to highlight that as well. So this is your acceleration. And just like the other ones, they tell you that the position at 0 is 2. So the first question says, is the speed of the particle increasing or decreasing? AKA, is it speeding up or slowing down? So we determine if something is speeding up or slowing down by looking at the sign of both velocity and acceleration at the same time. So for part A, we're going to look for the velocity at 5.5. And we're also going to look at acceleration at 5.5. So we do have to store these in our calculator. So here we go, menu, actions, define. And we're going to define v of t to be equal to, 2 times sine e raised to the control division t over 4 and then make sure you get out of that and then hit +1. Now, just a side note, I noticed I was in degree mode, so make sure you go into radian mode. And we're also going to define, since we need acceleration, we're also going to define acceleration, a parentheses t, as this beautiful function that it is, 1/2 e to the t over 4 times cosine of e to the t over 4. All right, so now we want to know velocity at 4. No, it does. Velocity at 5.5. So that's negative, and we want to know the acceleration at 5.5. So that's also negative. Now let's go ahead and write those down. So velocity at 5 is negative point. All right, here we go. Negative 0.45 337 and negative 1.35851. Okay, so because the signs are the same, this particle is slowing down, or in other words, the speed is decreasing because velocity at 5.5 and acceleration at 5.5 have the same sign. Okay, you could also have written here that this is less than 0 or that this is less than 0. All right, part B, find the average velocity. So the formula for average of a value of a function, in this case, average velocity, is equal to 1 over b minus a. I'm actually just going to write it down. From a to b. And then if we're talking about the average velocity, then in here needs to go the velocity function. So in this particular case, they want to know from 0 to 6. So we're integrating from b minus a, 6 minus 0, so it's going to be 6. And then we're integrating again from 0 to 6. You don't actually have to write the velocity function, just v of t dt. Now, they actually want us to find that. So now go ahead and plug that into your calculator. Control division. 1 over 6. Make sure you're always telling them what it is that you're plugging into your calculator. Don't just give an answer. Okay, especially now that the exam is all free response. We're going from 0 to 6. And the nice thing about storing a function is we can use it anywhere while in this document in the calculator. Okay, so 1.949, if you're going to truncate, at least 3 decimal places. So 1.9494. I'm actually going to move this over. There we go. 1.9494, or just 1.949 would have been fine as well. All right, part C. Find the total distance. I'm going to scroll this up. So again, total distance, we've done it on the previous problem. Okay, so total distance is equal to the integral of the absolute value of velocity from where the interval we're discussing, which is from 0 to 6. All right, so make sure you state that, and then of course we're just going to run and plug that into our calculator. So it's the integral from 0 to 6 of the absolute value of velocity. Which is 12.573. 12.573. All right, the last one, part D. For the interval from 0 to 6, the particle changes direction at least exactly once. Find the position at that time. All right, so we do need to first figure out where the particle changes direction. So a particle changes direction when velocity changes sign. So we need to find where velocity changes sign. So velocity changes sign at t equals, well, let's figure that out. Let's graph it. When you graph with respect to x, even though you have it stored with respect to t. So we're going to graph v sub x. All right, and again, menu, we're going to change our window to only go from 0 to 6 because that's the interval we're discussing. So you really don't want to look anywhere else because you might confuse yourself and give too many answers or whatever the case may be. So I'm going to analyze, find the 0 there, because it's going from above the x-axis to below the x-axis. So that's the time that velocity changes sign, which means that's where the particle changes direction. So it changes signs at t equals 5.19. Now I'm going to put extra decimals here. And when I use my calculator, I'm going to actually use even more than that because you're only allowed to round once per problem. And this is just the first part of this question. It's not the answer. So to determine the other position, we actually have to integrate using one of the known pieces of information, which was all the way at the top here, highlighted in blue. The position at 0 was 2. So we're going to use the position at 0 down here as the bottom limit of integration, and we're looking for what is the position at that 5.19552. So if we integrate velocity from 0 to 5.19552, it gives us our displacement or our change in position. So our change in position would have been the position when we were at 5.19552 minus our position when we started at 0. So we're going to plug that into our calculator, unlike the last problem where we had to do it by hand because it was non-calculator. This one you could just use your calculator to evaluate. So I'm going to go back home. I'm going to find the value from 0 to 5.19552 of velocity. So actually we already had, oh no we didn't. I thought we did. It was the absolute value that we had. So this is 12.13. I'm going to get some more decimal. 477 is equal to, we don't know the position at this time where it changed direction, but we do know the position at 0 was 2. So our position at the time where it changed direction is going to be the displacement plus that 2. So 14.1, and you could put 13477, or you can round it to 14.135. All right, so there you have it. As you can see, these linear motion problems tend to repeat themselves using the same types of questions. You know, is the particle speeding up or slowing down, or speed increasing or speed decreasing? Total distance questions, finding another position when given a position. All those types of questions repeat themselves. So hopefully by doing these problems, you get much better. Alrighty, that's all. Bye.